Thank you everyone for coming to our 50th meetup that TDI has done so far, which is really exciting. We have the pleasure of hosting several mass timber manufacturers for today's meetup. So we are really excited for the discussion and just to dive into this topic in general. So my name is Parker Ackerman. I'm the Marketing and Communications Coordinator for the TallWood Design Institute. Joining me is Ian MacDonald, who's the director of the TallWood Design Institute. And he will be doing some of the Q&A at the end of the meetup. Without further ado, I'll have each of our panelists go ahead and introduce themselves. So let's go Todd, Tyler, and then Michaela.
All right. Greetings, everyone. Todd Beyreuther. I'm in Spokane, Washington. I'm with Mercer Mass Timber, and I'm our director of product.
Howdy, gang. I'm Tyler Freres, VP at Freres Engineered Wood, and happy to be here with you all today.
Hi there. I'm Michaela Harms. I'm the Vice President of Mass Timber for Sterling Structural. We're a mass timber manufacturer out of Chicago, Illinois, and Lufkin, Texas.
Great. Thank you for joining us, everybody, from lots of different places across the country. So very exciting. So today we are obviously talking about industry and manufacturing, looking at some cutting edge projects, products, and other developments in the industry side of mass timber, talking about trends, things like that. And we really left it open to the presenters into how they wanted to kind of run with this topic. So we are basically just going to allow them to kind of share their insights and their inspiration to us here today. So I think we'll just go in that same order that we introduced ourselves in, if that sounds good to the presenters. So maybe I'll pass the baton here to Todd and he can open us up with his presentation.
Okay. And we're thinking 5 minutes?
We can do
more?
15 if you want
Perfect.
to. So
we can do that. Okay.
Yeah.
No problem. Okay. Well, thank you for this opportunity. So I thought it would be fun for me to show some of the work in progress. So often we're, presenting our companies in terms of the projects and the things that are in motion and competitive advantage on the project side and manufacturing. But my world is more of components and assemblies and trying to bring materials and things to markets we maybe haven't developed yet and maybe aren't the bread and butter of what you see behind me, which are, more standard big commercial office buildings and institutional buildings and so forth. So that's still our sweet spot up top, like others in the blue. But a lot of my focus lately has been on how we get into housing, industrial, and I know that that's shared by others on this call. In that, I've been spending all my time exploring different workflows also, not on the bid pathway, which is typical IFC to, CAD work to machine file, shop drawing, so forth, but rather really diving deep with Rhino inside, Grasshopper, doing a lot of the scripting stuff that we've been doing for years in architecture and structural engineering, which is my background. But then finding those workflows with Rhino inside Revit, Rhino inside CAD work, and trying to grab more of the APIs, and it's working. It's been fun and it needs a lot of engagement back and forth, even contractually, to figure this out. So obviously, big post and beam, bread and butter, interest in two-way, hybrid. Going really fast just because I'm just trying to get to some of the interesting R&D stuff we're doing. We do have a strong interest in cold form steel, bearing walls, so forth. But if you joined us last year at the Mass Timber Conference, I displayed a couple different structural build systems, and what these really were was test specimens. So we took 2 of these and we're trying to find the spectrum between load-bearing CLT walls all the way through what I call light timber framing with CLT. And it's we're trying to bring everything from the material, the components, the assemblies, and maybe even the systems through different code pathways. And I'm just going to go quickly through this because to get there, we need to focus on some of the grades of material. And what we're going to work on in the next grades we're bringing to market are electronically graded ELAM. And so I'm going to come right back to that after I get to some pictures from the lab. I can also touch a little bit on the LCA work we're doing from the sourcing. I'll stop here just for a second because what I just blew by was, if you're tracking the recent AWC EPDs for lumber, I'm really excited that collectively we're getting to regional sourcing so that we can start to account for LCA from whether we source from coastal US, inland US. We're working on inland Canada since our proximity in our Spokane and our Okanagan factories, and then of course the Southeast. And I don't mean this to be a presentation on environmental impacts, but because we have factories in both these corners, it's of a lot of interest to us to really start to dial that in, working longer term with partners on whole building LCA, all the way to mill and factory specific. But where I'm going with this is the ability to use different species and try to move the market more towards a performance-based specification that allows us more flexibility. I'm just showing the Pacific Northwest, but this applies to the Midwest, to the Northeast, when some of the different species that aren't as common in our mass timber products. And so in that, when I want to show some of the work in the lab, modular is one of those target markets that I mentioned. Obviously in industrial, so forth, but I think they all go together. But in the residential space, that leads us to thinking about certification of components, and those might be CLT and glulam framing. So the studs, the posts, the so forth, the sub-assemblies that start to displace bundled studs and others in light framing. But this is what it looks like, and this is what we're testing under some federal Forest Service money. So in the lab, we're trying to get towards more European type light timber construction. This is from Finland. We're in thinking about how we might reimagine decks. But this is the main target right now, is these shear wall systems that are equivalent with CLT studs and CLT framing. This is a whole different presentation, but I just want to kind of put out where the way we're thinking about this is to try to get to equivalency of light frame walls integrated with our mass timber systems. So, and then this is fresh. This is yesterday, taking some of these studs that are ripped out of the panels along with the bigger plates, and I have the preliminary data. I'm not ready to disclose it yet, just because we need to go through it. But really pleased and excited with where these strength properties are starting to land. And I think this will tie in a little bit later when Tyler and others start speaking, because this is kind of a really specialty of them also in getting into framing components with their product. So I'm going to quickly skip to what I would like to show more at Mass Timber Conference, and these are works in progress. I'm showing you right out of InDesign, but back to how we get there. And we think with our current grading capabilities, we want to make this or open to the industry, that we can start to move towards a stiffness and strength class of the lamb stock, but also of the material of CLT and GLT. So I'm showing you, these aren't real. So PLIB, if you're watching, I'm giving a little free plug here, that we think this is one of the agencies that can really dial in with us on whether on the left, the proposal that we're doing tension lamb stock in both CLT and glulam products, but it doesn't exclude our lumber or visually graded lumber on the right. So there's we can still use the NDS lumber values and qualify into those stiffness and strength classes. But what it requires from us as engineers and architects in particular is that we start specifying the performance requirements, not so much of the lamb stock like I'm showing you now, that we'll take care of that part. But as we start to get to to the CLT, it allows us a lot more flexibility in the different grades that we can of lamb stock that we can put into the CLT, and we can move something more towards something that looks like this in an ICCS report that is a stiffness class of CLT with a strength category, a lot more like we think about glue lamb. And then in this, you can see the CLT 3-ply 90 millimeter, and then that species specific that qualifies into this stress class. So this isn't real yet. This is the proposal, but we are moving towards that type of grade. And then what that looks like is we can still have our V and what prescriptively in the PRG 320 we call the E grades. I call them M grades because they're MSR, but then it also opens up for this rainbow of designing towards stiffness first, the different colors, and then within each one of those different strength categories. So I'm going to stop there. I know that's very geeky, but I thought maybe this was an ideal forum to throw a bunch of ideas out for feedback. And please find me before Mass Timber Conference, but also love to talk and get feedback and criticism on this. A lot of this is also informing some of the work that I enjoy and spend a lot of time at the code level. I'm currently on the State Building Code Council in Washington, and we've been working on a couple proposals, and one of those is to allow more of these flexible lamb stock grades in CLT. So okay, I'm going to take a breath. So thank you, everyone.
Great, thanks, Todd. I think the next person that will pass the baton to here is Tyler. So Tyler, if you want to go ahead and share your screen next.
Certainly. Is that working, everyone?
Yeah, we see
Looks
that.
good.
That was good. Okay, well, for some reason I'm not going into presentation mode, but there we go. Okay. So one of the things that people always talk about our product is that it looks a little bit different than CLT. We are CLT. We're approved under the same PRG 320 code. We have additional requirements under ASTM D5456 to qualify our material as a LVL grade prior to or structural composite lumber. But it does lead to a different characteristic when it comes to implementation in a building. So we have our current appearance options that we run with right now. On the left is our standard architectural appearance for the inside of the building, with an example of a steel hybrid structure that we did recently over in Bend, just as a wall for it. The one on the right is our more improved material that we call our HD material. That's essentially we compose together flechettes of clear veneer in order to create a much more refined, almost not freeze-over appearance for it. And you can see what that looks like when it actually is implemented within a roof structure. But we're working on a couple other things here, and this is something that we've been implementing for a little while, but it's really coming to fruition, where we essentially break our 4-foot wide panels down into smaller subsections and then reintroduce them into the system. So what that allows us is that you can end up with much more of a board appearance like you would have with a typical CLT product, but with the same type of performance that you would get with a built-up LVL panel. So to be clear, the one on the left is exactly like how we make our normal material, but just the outer layer is broken down into more randomized boards, so you can end up with a little bit more of a randomized appearance, randomized hues and tones throughout the entire material. And the one on the right is exactly like our HD material, where we've done the same thing and broken it down into separate sections to create that kind of randomized appearance with hue. A couple other things we're working on is an edge grain appearance. And we actually have this in place on in our warehouse structure on our own site. And it's a beautiful type of appearance. Unfortunately, at this period of time, we can't count that outer layer towards our structural performance. We know it adds to it, but we essentially have to be a monolithic sort of layup with all of our LVL grades within a material, and it's really difficult for us to get qualified with adding this sort of differing grain pattern within a MPP panel. And the one on the right is something that we've done for a couple of small structures around the area, but it's essentially a Shosugibon sort of exterior appearance where we've provided kind of a alligator peel sort of texture to our structural product. We're going to have this tested here pretty soon, but there's significant potential for us to get a Class A fire rating or flame spread rating on that material. So we're crossing our fingers. As far as testing and certification, we've had a couple of changes to our product report. So I just want to highlight those for people. And I would always suggest, if you have any questions or you're considering a project with our mass ply materials, please go to the APA report and download the latest report. So these were revised as of December 16th, so they're very, very recent. So one of the biggest changes that we were able to verify through testing is down with our shear values for our 2.1E, 1.9E, and all the way down to our 1.0E. So before we had a lesser shear value at 260, and so we've been able to test and verify that we've got a 285 shear, horizontal shear. So we've also been incorporating a lot more of our F21 or our 2.1E material into beams and columns for an enhanced performance. We have a little bit of concerns about that because with all parallel veneer, as sometimes you can end up with a little bit of cupping and dimensional stability issues. So typically, if we're looking at beam and column applications, we usually push people towards our 1.9E material because that has a little bit of cross banding in it to make sure that we can maintain the dimensional stability of the material. So our 1.0E, if people aren't aware of it, that's typically a material that we use for a point supported slab. So something that has two-way action within it. It has about the same performance across the minor force direction as you have it with the major, but I'll jump into that a little bit more too. Recently, this last year, we completed some additional blast testing with the Department of State and the DoD. I figured it's always fun to show a video of something exploding. So in particular, the two materials that they tested here were a 4-ply or a 4.08-inch material, as well as a 6-ply or a 6.12-inch material. The 4-inch did fracture across the middle section of it, but still was considered moderate damage. But the 6-inch there was no significant damage whatsoever to the panel. And these tests were all conducted under the auspices of the Department of State at the Tyndall Air Force Base in Florida. So luckily this last year as well, we were able to complete a point supported slab testing down at Oregon State University with the REACTS program. Got to thank Ian and the rest of the team down there for helping us coordinate this testing. It was really important for us to get this in the works. And I can happily say that as of yesterday, we've received the final non-draft report. So that's available if anyone has any interest in point supported slab for multi-story construction. So essentially, we ended up testing those panels on a 12-foot by 16-foot grid. The panels themselves were 12-foot by 32-foot with a 5-ply and a 6-ply. You can kind of see some of the performance results there, but I mean, at the end of the day, we were able to substantiate a 12-foot minor force direction span, 16-foot major force direction span with a 6-inch panel. And this is important for these types of structures. This is the Oh Wow 1510 Webster project that we did in Oakland this last year. This is 19 stories total. 16 stories over 3 stories of concrete. Very, very quick project, very successful, and we're really happy about our partners down at Oh Wow. They're currently considering another 8-story as well as a 24-story in the future. So they've been very good partners with us for these types of building constructions. This is a project that we just finished shipping the last panels to, but I figured it would be a good example to show you guys as far as what we're able to do with our mass ply lambs as substitutes for glue lamb material, but also with our large format panels. These were very thick panels. A lot of them were up to about 9 inches, and so were the beams. The beams are sistered together into 27-inch wide sections, and they're all on a curvature over the entire roof. They also chose to go with our high HD appearance. So this is predominantly a clear veneer roof and also on the beams themselves. So really nice aesthetic, and really one that I'm looking forward to visiting in person here in the near future. And we've done a lot of wood and steel hybrid structures over the last couple of years. These are a couple very recent ones. The one on the left is Lane Community College here in Oregon. It's just south of us, just south of Eugene by about a half an hour or so. And then we have Bend, Oregon. This is Juniper Ridge. It's the City of Bend Public Works project, with the intent that these wood panels will remain visible throughout the interior of the structure. So one of the areas that we really want to get into is our warehouses and data centers. It's kind of been the talk of the town. The amount of investment and infrastructure they intend to put into data centers here in the near future is mind-boggling. As we all know, the tech industry is probably one of the most environmentally, they create a lot of environmental issues with the fact that they consume a ton of energy. They have a whole lot of rare earth metals. And so they've got to find some way to get a little bit of environmental virtue into their system. So, wood structures is a great way to sequester carbon right at the beginning of the building. So we're really looking at these types of structures. This warehouse is 59,000 square feet. It's the grid structure was on 40 foot by 48 foot. The walls we did much like a concrete tilt-up construction where there's no exterior beam or column. It's the exterior walls are 4 inches and the roof joists are supported by the walls. So this project essentially went up in 6 weeks of construction. Our general contractor figured that this shaved 3 to 4 months off of a typical tilt-up construction. So it was very, very time sensitive. It went up quickly. We poured the slab in the beginning of June, and we had occupancy by the end of September. In total, we came in about $113 a square foot on this project. So the fact is, I think we're going to be competitive with any type of pre-engineered metal building out there. So if anyone has any warehouses that they're quoting or looking to put a warehouse in on their site, please consider wood first and give us a chance to quote on that. And we've been doing a lot more long span beams and a lot longer spans. So, for the gymnasium up in the top left corner, that was about an 80-foot span with some steel plate moment connections in it. We've also done 65-foot spans just with more of an arch, and also our longest span that we've done so far just with our material is a 96-foot span, but that's with 2 pieces coming together up at the top ridge. And like I said, the Woodland Park Zoo has a pretty significant span built into it as well. So what we really like to do is to be able to take the entire structure, not just the panels themselves, but also the beams and columns. The one thing to keep in mind if you're asking us to work on the beams and columns is that we are very size sensitive. So almost all of our beams and columns are nested within a 4-foot width. So to the extent that we can make things a good multiple of within that 4 foot, the more cost effective the material is. But it's definitely something that we like to do, especially with columns. Our typical sizing are about 14 inches by 16 inches for a lot of the point supported systems. So with that is about all I have. Thank you guys very much for your time.
Great. Thank you, Tyler, for that presentation. That's great. So last but not least, we'll pass the baton to Michaela, and then we'll enter into a Q&A with Ian.
Wonderful. Thank you so much. I'm going to see if this, how we look in here? 1 second. Is that looking all right?
Yes.
Wonderful. Thank you guys so much. So I'm Michaela. I'm with Sterling, and I run our structural division. And I just kind of want to talk about, we're really interested in how modular approaches can improve accessibility and affordability for mass timber projects. So I'm going to walk through 3 different approaches to kind of more productized as opposed to volumetric modular, but how that's been working really nicely for these affordable projects.
Hey, Michaela, you're not in presenter mode. We're seeing like
Oh, I'm so
like
sorry.
dark
I'm seeing
thing.
it in presenter mode. So sorry about that, you guys.
No worries.
Thank you. Thanks for letting me know.
All good.
Let's see. This is funny. I've never had it do this before. There we go. Let's see if this works. Is that now in presenter mode?
Yep, it's all good.
Okay. Thank you so much. Thanks for letting me know. We're a Teams group, so sometimes I'm not as good on Zoom. I appreciate that. So Sterling we're really focused on how we can standardize the CLT as a product specifically for scale and repeatable delivery. We think it's a great opportunity for our built environment from a sustainability perspective, because if we look at mass timber buildings, about 75% of that carbon sequestration is really in the slabs, in the floor and roof systems. So that's where we try to focus. We try to be a little bit more agnostic when it comes to beams and columns and things like that, and working with lots of different partners, but really to get this into as many building types as possible. And this mentality towards modularity really comes from what our roots are. So Sterling's been manufacturing CLT since 2015. And we are the largest manufacturer of CLT in the world, but the majority of that currently, not for long hopefully, but currently goes to our industrial matting business. So this is a really cool application of cross-laminated timber and wood products that not many of us see every day. There's so much infrastructure development out there, and this is materials using forest resources, and we're not treating these, so we're not introducing anything into the environment, and it's just a really fun, exciting other part of the mass timber industry that we don't talk about very often. So I always like to go back to our roots. And the reason I go back to it is because, as you can see here, these are just many, many, many rectangles. And so our manufacturing facility is set up to produce at this type of volume. So we make a panel every 65 seconds. And so when we think about that, we go, all right, how can we start to make more of a module approach, a productized module approach to the mass timber industry, so that we can get into really scalable development and use that ability to produce very quickly, and get this product into more building types and a wider construction market. So how can we compete with steel decking and precast concrete and all of that kind of stuff? And so the industry, from the steel decking perspective, is very used to specific sizes and working off of those type of modules. We run on a 14, 16, and 18-foot length module, and that's all based on the existing lumber supply chain. So we're one of the largest private purchasers of Southern pine, so we get great pricing. And we're able to then just take that 14 and 16 and 18 foot and then 8 foot in the cross layer stock lumber that is sold for many other uses, and bring it right into our line and turn it into our cross laminated timber. So that's what guides the initial modules. And then now we're really working with designers to say, okay, how can we, it's great to be able to make these very complex CNC structures, but it's not the most cost effective, and it's not the most waste effective. So how can we start from this module and maybe limit fabrication first to 50% of panels, and then maybe limit fabrication to 20%, and then maybe even 10%, so that it's becoming more of a distribution commodity style product. And so the first project that we will look at that is kind of taking this approach, this is from Cutler Development. They're a development team based out of Des Moines, Iowa. So when we talk about affordability, when you're in the Midwest, affordability and affordable housing is a very different point than on the coast. And so they've really done an excellent job of looking at what the formula is to get mass timber into their buildings and make it pencil. So we worked with them again to kind of maximize their construction with that module approach, focusing on those repeatable standard grids, and understanding the efficiencies from our perspective and working with their design team so they understand kind of the design for manufacture. Where does it really make sense to add in that extra fabrication, and where does it make sense to not do that? And so you can kind of see here, based on different grids and different building typologies, how we can kind of look more at starting with that module from the very beginning to create this very repeatable, these very repeatable elements that are then also much easier from the logistics and sequencing perspective, because now not every single panel is an individual custom panel. And so we work with these teams to keep it very repeatable, and balance all of that, and working with other installers and GCs to be sure that we're doing kind of the things that make it the easiest on site. So a second approach that we've been working on is more from the industrialized construction program approach. So this one is out of Northwest Arkansas, and this team really wanted to use mass timber. They wanted to support Southern pine, and then they're really prioritizing sustainability to bring in a good workforce. How can we make housing and environments that people want to come live in, because they have such a need for workers in that region, and bringing more people in. So we talk about this kind of level of product standardization and versus level of offsite assembly. And this is really how we started to build out this industrialized construction program. And so again, we really wanted to take a little bit more of that productized and panelized approach. So looking at kind of the CLT floor systems alongside modular bathrooms and kitchens, which made a lot of sense for this specific construction type. And it's a little bit more optimal for this specific project than a full volumetric dwelling unit. And we worked on this with some excellent team, Aspect, Modus Studio, Modly, Blue Crane's developer. It's 60 units of conventional construction. So this is a really unique project in that half of it is 2 buildings that will be stick frame, and half of it is this industrialized construction approach. And so the developer is actually going to release all this information of what they learned as a cost comparison for both of these approaches on the same site, which we think will be very exciting, and hopefully something with release through Woodworks. But this, as we looked at the kind of productized approach, we really broke it down by zones with this team to look at optimization of mixing 3 and 5 ply panels for the zones where they were required. And that really got this one to an excellent price point to make these structures a bit more affordable. And so here's kind of some examples of test fits for those different areas. And then that, again, seeing how that module extends all the way through the different levels of these 2 buildings. We all know this, and I don't think we can say it enough. Contracting early and getting the design team, the architect, engineer, and construction teams together early tends to really help keep these projects streamlined and going forward quickly. And what we found was, with this project specifically, is at this point, we're already within 5% of the stick built cost. So we're excited to add in what we think we'll get out of the schedule gains. And contracting early, planning long, and executing fast is really the name of the game when it comes to this industrialized construction program. And then last but not least, this is right in the Midwest. We've been working with Homestretch Development. They do exclusively workforce housing currently in Michigan. And he was another great approach of, hey, where can this make sense within my building? And so for all of his projects, we're focused exclusively on the floors. So it's a mix of SIPs and traditional stick frame and CLT floors. And it's been really cool to kind of see how all of his specific projects are coming together. And we're looking now, as we've built out this program, I think we're on our 5th or 6th building with Homestretch, incorporating Michigan wood into the project. And so why we talk about contracting early is because manufacturers, especially when they're able to work with the architect, engineer, and construction teams, can offer a lot of these extra design assist, project management resources that if you're in with the collaboration early, you get the most benefit from. We learn a lot. We still do projects where we come in late and we learn that it's just not as efficient. And so we're trying to work with these teams to continue to build out better collaborative and early approaches here. So I'm glad that Todd is bringing up the different species and kind of some of those more performance-based metrics. Obviously, Sterling is a little bit of a different on that approach, that we're trying to buy exclusively #2 material directly off of the market. And so right now we're selling Southern Pine out of the South. And then we have been certified now for Pine Fir South, and have been focusing our sourcing for those in the upper Midwest, the Great Lakes region, and New England, and then also Eastern Hemlock from those 2 regions as well. And so by adding to our offerings, we're hoping to work with different teams that want to be utilizing their local resources directly into their projects. Sterling currently and will always buy 100% US wood. And we try to work with glulam manufacturers as well who are buying US wood, again, to just keep that regional sourcing story present for these buildings. And so, again, from the specification standpoint, we think it's really important to make sure we're sharing with teams that that they understand the impacts of those specifications. I love the move towards a performance-based specification because it does give all the manufacturers the opportunity to put the best product forward for that project. Because when we add on some of the extra certifications, sometimes that can really limit the supply chain, for example, or if we have a very prescriptive only this grade, again, it can really limit the opportunities of the supply chain. And that ends up making lead times a bit longer. Freight can be more complicated. There's an opportunity for infinite layups, but what's really available on the market? So we were to kind of educate teams on what we have available, what we know our glulam partners have available, what's available on the market in general, so that we can compare those things. And we think certifications like FSC, SFI, and all of the extra things are great, but we also don't want that to be the reason that you went with European wood or the reason that you didn't go with wood at all. So it's important to really think about what those specifications can do to a project. And then finally, really comparing costs holistically. We're really excited about the industrialized construction program results because we'll be able to actually have real built projects on the same site next to each other, where we can compare that entire structure, the entire construction life cycle, and everything like that. And which off-site items are included in the factory versus not. Those are things that we think really help that better comparison so that we know we're really going apples to apples. And then another big one is regional labor pools are so different in so many regions. And so what we've learned is really getting those installers involved as early as possible can make the project more efficient. It can help you understand, hey, if your MEP is really late, you really got to talk to your installers because maybe they're better off cutting the holes for that stuff on site. It's not always the answer, but it's good to have that conversation early. We had a project where they had wonderful timber framers on their team, and they bought direct commodity glulam and cut everything on site themselves. And it was great for that project, but I can tell you that doesn't work for every project. So having those conversations are important. And that is where we are at currently. So thank you so much.
Great. Thanks so much, everybody. So, I mean, I have a few questions that I thought of while I was listening to you three guys talk, but maybe I'll offer the other participants the chance to ask their questions first. You can either unmute and go on camera, or you don't have to go on camera if you don't want to, or you can throw it in the chat if you prefer to do it that way. But, you know, if you have anything you want to ask of these three presenters, please go ahead right now. You can hold up your hand as well if you're one of those orderly people too.
Yeah, Adam put something. Should I respond to that? So here, I'll read it. Thank you, Adam Slivers. So it says, it seems like your grading and performance proposal is built from supply. Have you thought about the demand for the wider variety of products? For example, it would seem some of these new ratings might be more applicable to CLT walls or studs. Okay, I think I got it. Thank you, Adam. Yeah, in fact, maybe you are kind of seeding that, where that's one of the, so these new grades, these new ELAM grades that I'm proposing, but really what they are, they can be visual, and they're more homogeneous though. And so some of the research that we've been working on or bringing over from some time spent over in Europe in the Austrian labs is the properties of these two-way slabs really want to be more homogeneous when you're dealing with some of the great stuff like Tyler's working on with the punching shear, the rolling shear around, point supported. We're trying to think about what that means in lamstock based CLT. But yeah, when we get to these components, same thing. And I'll just give a quick example, and happy to get feedback or criticism. But as I was breaking these homogeneous studs yesterday, is the first time that I've had a chance to break a lot of wood, but haven't taken it down to narrow members. And we're trying to start to understand a little better what that means when we go from 4 lambs to 2 lambs to 1 lamb. And now we start to go to splitter stock equivalency, right? At a 2.5 inch, right? And what does that mean? And it was really interesting. We could get these short, this is getting a little maybe deep in the technical side, but we can get these shorter span studs. They'll tip rakely in tension if you get a finger joint or a knot like normal, but they were building up a lot of stress, and then were pretty explosive compared to a wider CLT panel that redistributes, kind of talks to you at 40-50% load, and then eventually has a failure mechanism. But as expected, this is a narrow member, builds up, and bam, explodes out. So just little things like that seem small, but they tend to point, in my opinion, more towards homogeneous grades, whether they're low grades or high grades, because we're now looking for those properties in the transverse layers, that we're not just dumping the low grade in there. So that's one example.
Maybe I'll pitch one in here. So, all of you kind of talked about sort of maybe the evolving market in different ways. Tyler, you talked about, different opportunities to put different kinds of appearance on MPP, but you also talked about the opportunity to crack into the sort of warehouse and data center market. I think, Todd, you're talking about maybe modularity and how you can get into housing. Michaela, you're talking about repeatable kind of, systems. Is this in kind of respond to market dynamics, or are you sort of being actively solicited to come up with these kinds of products in response to customer needs? Just curious how you see, it's been a few years that we've been doing mass timber in the US now, and just curious to see how you see the market kind of evolving. Obviously, I think there's been a lull in commercial construction, like office construction. Maybe that's driving some of this. Just curious to get your thoughts on why this is happening now.
Maybe I can touch on a couple of things there. I would definitely say a lot of this is coming from the need for housing, the interest in the material. I mean, I think Tyler and Todd can definitely both attest to, and I'm glad Tyler brought it up, is like the warehouse and data center space is definitely driving a lot of these conversations and driving a lot of innovation. But I also think, the mass timber and the just wood products industry is unique, and I think from my perspective, and maybe I'm a little biased, but it's really an industry where manufacturers and academia and the industry in general are trying to always stay ahead and doing the extra testing and trying to build out different products. You think back to even like iJoist or Glulam way early on. So I think it's a mix of the two, but from our perspective, the need for affordable housing and the interest in domestic product and domestic manufacturing is driving a lot of what we're doing. And then obviously the data and warehouse center space.
I would agree with Michaela on this. I mean, we are definitely customer driven in a lot of ways, in that we respond to what people are asking of us and what's within our current production capabilities. I would say that, though, that we all have strengths and weaknesses when it comes with the types of products we produce. And we always say that our manufacturing equipment has significant limitations for the types of products we can make, and so we try to make sure that people understand that. But also has several benefits, like for the warehouse roof section and for the roof up at the Portland Airport. Those were 2-inch panels, which makes it very cost effective on a 12-foot span in order to create a very large format roof section very quickly. So that's just one of the areas in which that we excel pretty darn well, is creating much thinner approved elements. The other thing is the point supported slab. That's something that we've had a lot of requests for, and it's something that I think our material lends itself to, just because of the fact that we have so many laminations. Say in a six ply lamination, we have 54 veneer layers. That means we can change the orientation of any layer within that 6-inch element in order to achieve some of the design properties that people are looking for. So I think we all try to promote those products and those systems, like the modular or the prefabrication, that really fit the types of material that we make and use.
Todd, do you want to chime in on that?
Well, if you entertain a diagram, so yeah, it's we need to grow the market, and we need to grow the market to we're not an industry yet, and by definitions, we're less than 5% of the market, which means we're very good as an industry saying, hey, we like doing these big commercial, institutional, so forth buildings because they compete with a steel and concrete construction type, so they're cost competitive, and they are. But how do we become cost competitive in industrial? How do we become cost competitive in housing? You're hearing a common theme there from all the manufacturers. And I show this diagram, and it probably needs a little more unpacking, but we've done market diffusion models collectively, the state of Washington with University of Washington Center for Program and Hartwood at the time, and believe the models or not, but the intent here is showed on the bottom, we're in this pathway of slower growth. I know you see a lot of diagrams of hockey sticking in the market and so forth, but you also have to look at how fast a product diffuses into the market and what can we do to accelerate it. And so some of the common themes you're hearing about, like Sterling saying, hey, well, here's the strategy of standardization of trying to drive down that cost. I was recently reverse engineering with a partner why they're going through and looking at multiple bids, and they all were landed in about the same ballpark, and they said, oh, they're all 3% over. And that, if you were a mature technology, you'd say, well, we're losing. If you're an emerging technology, an investor would say, all right, that's what I'm going to put my money into. You're winning, because now if you can pull 5-10% out in an emerging technology, and scale is one of those strategies, but also just good design is also so. This is my hockey stick diagram, but it just doesn't happen. You have to invest in those phase shifts.
Right. Yeah. Thanks. There's a question in the chat from Carmichael, who says, "Do we have examples of housing projects in the Northwest where these products have been used?" Carmichael, I don't know if that's aimed at a particular company's products or just the products you heard about today, but care to elaborate on that?
Hi, everyone. My name is McCrae Carmichael. I work for the Mid-Willamette Valley Council of Governments, and I'm also the executive director of our Economic Development District for Marion, Polk, and Yamhill counties. And all the districts are working on housing projects, how we assist our members with having more housing. So I'm new to Mass Timber. Like it's been on the periphery. I'm curious. Somehow I got to this meeting, I'm listening, and I hear things and I think, right? So what is it? You know, where is there, have any of you all, anyone in the whole meeting, do you have examples of housing projects in communities that have happened? You know, I'm Oregon based, but I think there's people outside of Oregon. So new and just asking to learn more. Is there a list somewhere? You know, like, is there like a,
Oh, yeah.
yeah,
You should go to Woodworks. Woodworks lists everything. They have the Wood Innovation Network.
okay.
And so that's where you can see, I mean, there are projects all over the country, and it's really cool to see it right on a map.
I don't want all over the country. I want here. I want
Yeah,
Northwest.
well, you can zoom right into where you want to look at. They have the
Oh,
whole
okay.
map, and you can zoom in.
Okay.
Yeah.
Can you drop it in the chat? Thank you.
Yeah, and I would say that yeah, to date the housing solutions have mostly multifamily residential, rather than kind of smaller, modular structures. There's a lot of interest right now in using mass timber and modular structures, but Todd showed some of the approaches they're working on. There's a variety out there, but I would say that's being a little bit harder nut to crack, because some of the benefits you get from mass timber when you have a fast speed of construction. So the bigger the building, the more kind of economies of scale you can get there, right? But I'm sure there are a number of, I mean, Oregon is pretty ripe with mass timber projects in general. Housing is being a bit slower, but there's a lot of thought going into that right now. And Tyler, I don't know if you can think of any particular projects you would want to highlight, either in Oregon or California or.
I mean, absolutely. I'm assuming Mid-Willamette Valley or Salem area. So, if you want to get in touch, I can take you through Salem Public Works, Schmecketa, but up in Portland, we've got a 12-story and a 10-story Minnesota Places and Park that are both multifamily structures just in Portland. So there's a lot of examples around here. I'd be happy to get you a list of them.
And I would just note quickly on your comment, Ian, about kind of smaller single family housing, like an approach we're looking at with lots of more, again, Midwest based. So I'm sorry, I know you guys are always talking Northwest, but more Midwest based. We've got a little more land in some areas, and like a lot of places that really need, like these second and third tier cities that are building out, and they're building those bigger single family homes still, and that's the typology there, and you have to just understand that that's what they're looking for. And so we believe that kind of the single family tract development mentality, working with those builders and understanding, like on my third one, the third example out of Michigan, understanding where mass timber makes sense in those types of constructions, and then using the scale of, hey, I'm making 500 units to make all the numbers work properly. There's quite a few developers popping up in the Nashvilles, the St. Louises, and those types of second and third tier cities that are really interested in using mass timber for scaled single family development as well.
Yeah, thanks, Mike.
If I could just do a quick shout out too, just because I see some people on this call that actually have some interest in some of this. With the TallWood Design Institute and designed by Judith Schein was the mass ply, more modular construction that's currently down at the Emerson Lab. So that's a pretty fantastic example of what a prefabricated single family structure could look like. So thank you, Judith, appreciated. And then Trent Depth with Timber Builder constructed an all LVL building down in Austin, Texas. That's really unique in the fact that it's using much thinner LVL elements in order to pre-construct an entire building. So shout out to Trent too.
Judith, do you want to say anything about the mass supply panel prototyping project that you've been leading?
Thanks. Thanks, Tyler, for the shout out. I will say that we think it's about to leave the Emerson lab and be the first prototype and be relocated up to the port in a warehouse where should we be able to manage all this in the right time frame, it'll be on display. We as Tyler said, it's about a 760 square foot, 2-story panelized mass plywood house designed really as part of a cottage cluster or for ADUs. And we are now working on optimizing it for a second prototype that we're going to send out for a bid for a contractor to build. We hope in a few weeks. So once we get that up, we'll have another open house. We'll invite everybody to go see that one, which is going to be constructed outside at the Emerson lab. And if you're interested in it, we have lots of video and articles and things we can send. But thanks again, Tyler, for the shout out. Yeah, we're very excited about it. And oh, I should say it was funded by our big EDA Build Back Better Regional Challenge grant. Yeah.
Thanks, Judith. We talked a bit about different drivers and movements in the marketplace. In the research community, we are always asking the industry, what are the barriers and challenges, because we want to, oftentimes we can maybe affect those through research or through generating some data that helps provide some clarity on the performance. Like the example that Tyler mentioned, the point support testing. This was done originally in Canada, in Vancouver, for the 18-story Brock Commons building, but the data never really made its way out into the public domain fully. And so we recently tested point-supported system configuration panels, both CLT and MPP, and we're actually have an ongoing project to do looking more at the behavior of those point-supported systems. But the idea being we can put that information in the public domain, people can take that and use it to get code, buildings approved and permitted. I'm curious, we always ask this question, but it's always of interest to me, is, now that we've had a few years where we've been making mass timber in this country, are you seeing different barriers and challenges? Are you seeing some of them fall away and others become more more concern? Just curious what your take is on that.
I can share. I saw Tyler on mute also, though. Go ahead, Tyler.
Go ahead, Todd. I'll jump in a second.
Okay, I'll be quick. So in 2014, the state of Washington, we put together this coalition and we're kind of bringing it back, and it's been helped to be in parallel with Oregon and help Oregon encourage Washington to get going again. But my point is back then we defined barriers, and that was part of those the risk to market diffusion in the model I showed you earlier. And it was the typical stuff, the codes and jurisdictions, architects and engineers use it. And then most importantly, can we get the cost down? And we knew we can work on the cost over time, and now we're 5 to 10 years into it, and we're starting to get a little bit of a feel for that. What I'm constantly surprised about is aligning on a status quo that gets just a little too, too prescriptive. And I feel again, there's a lot of room for innovation in this, and I would hate to see us get in this rut of, yeah, but it has to be, this prescriptive grade out of PRG 329. I'm getting specific, but it's been one of the challenges to get to this performance specification. And I don't just mean the material. We have a group of industry people that have been traveling the world with the ModX group to understand manufacturing and codes and standards in Sweden and Japan and UK and Austria, Switzerland, and so forth. And what's been fascinating about it is the effect. If you can do this pre-approval, these performance grades, and like in Sweden, they just threw out their prescriptive residential code. And saw, I think some of the statistics they were giving were a 20% drop in cost and an increase in speed and so forth, because they just eliminated, all the conservatism that's built in there that just put them on a pathway without innovation. So that's what I was surprised about in my last 5 to 10 years of this journey.
Thanks, Todd. Tyler, I'm sure you want to jump in here.
Yeah, I mean, this, me And if I have the opportunity to talk about forest management and responsible forests, it's the thing I want to talk about. And to the fact that, I mean, let's be honest here, a lot of the entire US marketplace is currently taken up by European and Canadian wood. People talk about the fact that they want to be locally sourced and they want to go forest to frame. But to me, it's really sad to see, essentially wood imported from across the pond all the way up in Portland, Oregon. So we have a fantastic forest resource here. What people don't realize is that the cost of our material is entirely based upon the cost of the timber that we buy. So we are a primary manufacturer all the way from tree to finished product. So the cost of the raw material is about 75% of our overall cost. Now imagine that. That's such an enormous portion of the cost. So if you really want to have cost-effective wood buildings out there, carbon sequestrating, healthy, biophilic, wonderful new buildings built, we need to become true advocates for forest management in especially in Oregon. So we're still on the downward cycle of locking up more forests and encouraging forest fires, in my opinion, that we need to be a little bit more active within our forests. And I see nothing but good results. So forest management will end up with cheaper materials for everybody that are trying to build cheaper homes. It will end up with healthier forests. It will end up with more prosperous rural communities. And it will end up with better drinking water. It has nothing but wonderful outcomes. And at the end of the day, what we end up with is more resilient forests that are not as susceptible to wildfire. So let's try and make wildfires a thing of the past. Let's start managing our resources and do something good in the environment instead of ignoring it and anticipate that nature's going to do only good.
And so, Tyler, in a perfect world, what changes would happen so that would be possible? Like in terms of what changes would have to happen in terms of forest management policy or regulations or?
Well, so amazingly enough, I think there's a huge opportunity right now because, last year, the Biden administration opened up the review of the Northwest Forest Plan, which has essentially been the harvest plan that we've been operating under for the last 30 years. And what it has allowed is rampant and unrestrained litigation towards very beneficial fuel reduction and thinning and forest management projects. So it's essentially put the Forest Service in Oregon in a stasis where they can't do anything. So, the federal government owns 60% of our state. They provide less than 8% of the harvest. If we want better quality wood products, we need to look towards the federal land. If we want to stop doing the having wildfires, we need to look towards the federal land because the private land is tapped out as far as, they're decreasing the growth cycles as opposed to increasing them. And I think we would all like to see something closer to an 80-year cycle on Douglas fir up in the Northwest. But amazingly enough, the Congress just passed the Fix Our Forests Act, which I think is going to limit some of the environmental litigation that's going to happen on federal lands. And they're set to make additional legislation in order to reduce the litigation. And litigation is the big thing. I mean, that's what's really put the Forest Service on its heels. Oh, man.
I would just love to add to that because I think that from our perspective, like this is a very critical barrier. And obviously like we're not working in the Pacific Northwest forest, but the story's the same across the country. And it absolutely kills me, especially in Wisconsin, when I keep seeing, timber from Austria or timber from Germany, and they make great products, but we have such an amazing resource here that needs to be utilized. And I think Tyler is just like absolutely hitting the nail on the head with many things, but one thing that I see consistently is if you put FSC on your specification, you have eliminated any opportunity to use timber from federal lands. They cannot certify those lands. It doesn't mean it's bad forestry. And I think that at a really strong concerted effort that I think everyone, all three of us here and TallWood Design Institute too, like we've really tried to work strong. We really tried to work to educate architects on forestry. Like US forestry is great forestry. And our timberlands are growing, they're regenerating, and some of them are way too overstocked. And what Taylor's saying is we are part of nature. We don't just leave nature alone, we're part of it. And we need to keep building into those relationships and fostering what stewardship looks like, and then educating architects about it. Because there's been too many committees in my experience where we're talking about wood transparency and wood sourcing and all these types of things, where it's a room full of architects and there's no foresters and there's no one from the supply chain. And so it's really important to recreate that connection between foresters who know more than any of us will know about stuff like that. You know, Tyler's probably as connected as more connected than any of us. And beautiful forests there. I love that area. But it's so important. You know, we've done like AIA presentations where we actually take the architects and walk them out in the forest, and it does make a big difference. And so that would just be one thing that I would add that's been a real barrier for making sure we get these products in. You know, we've had projects where we were like, hey, you have your Wisconsin project, we'll give you Wisconsin wood, and they wouldn't budge on FSC, and they ended up getting it from Austria for the better sustainability story. And that was just a really hard pill to swallow. And I think we all just need to work together to better educate ourselves on forestry and regenerative forest management.
Right. I want to ask a kind of follow-up question, maybe back to Tyler again, but also feel free to anyone to answer. There's a related question in the chat saying, is anyone making mass timber from small diameter trees? Can small diameter trees pay for getting them out of the forest? And I think, Tyler, you can speak to, you know, using very small trees and veneer-based products in particular. I don't know if you want to talk to that, but then my sort of follow-up question to your comments, Tyler, was, do you think that, you know, there's obviously a need for forest restoration, as you say, because of the increasing prevalence of wildfires? And I don't think there's more wildfires. I think it's just that they are more intense and they burn bigger areas. The actual frequency of the fires themselves, I don't think has changed. I read that recently. You know, could we solve the fiber supply issue for mass timber completely just through restoration forestry, or do you think more kind of significant changes need to be made at the federal forest level, doing clear cuts and that kind of thing?
Yeah, I think it's a fantastic question, Ian. And so, you know, on the functional basis, I'll answer this diameter question first. Yeah, at our small log plant, our average block diameter is only 8 inches. So we can use small diameter timber. In fact, that's our preferred. In fact, right now, it's not even available. We had to raise our upper limit to buy logs for our small log plant to 14 inches. We would like to buy more small timber, but it's not being made available out there. So the federal government has a huge amount of supply and the amount of forest. In fact, I think the last stat I saw is that they have 5 million acres of fire-prone land that needs to be treated. And we're happy to thin that entire environment. As just from math, you know, we can get about 10,000 board feet per acre off of a good thinning project. We use 100 million board feet annually. That means that we could treat 10,000 acres annually of a 5 million acre problem. So the amount of timber that's out there that really needs to be resolved is really important. And, you know, we take it very seriously around here. We experienced the Beachy Creek fire, and we lost 1,200 structures and homes in our region. And it was really a traumatic event. But I could tell you that, you know, people look at it and they say, hey, it's sad when your neighbor loses their home, but it's a disaster when you lose your own. And I think they're experiencing that down in LA right now. I think it's really a sad deal. So there's a lot that we can do across the forest landscape in this area, and we're happy to do 100% thinning. I do want to mention that, you know, clear cuts are still a silvicultural goal. I mean, at the end of the day, they're not destructive. They provide the open areas for flora and fauna, butterflies. I mean, there's reasons to do clear cuts within the system. They're not entirely a destructive activity. They're actually a silvicultural goal. So did I answer all your questions there, Ian?
Yeah, you did. Thanks, Tyler. Very succinctly. Yeah, any of the other panelists want to weigh in on this? I mean, Todd, you're up in the Spokane Valley. There's restoration work going up in northeastern Washington as well, right?
Yeah, I think the part that I can contribute is the reason we're doing all the multi-species electronic grades is to allow for that diversity. when I first came over at the time to Katera out of Washington State University, where we were doing techno-economic analysis of our region, where do you put these things and get them to the market and so forth? The answer was, where Tyler is, or Longview, Washington, or Spokane, Washington. And we landed in Spokane, to be part of that solution, if you want to call it that, or to at least contribute to it. But to do that, we had to be able to be flexible to diversity of species. Now, there are other reasons why we became heavy and landed on importing from Canada and so forth. And that's what we're still 5 years into it, are trying to get to. And hopefully by adding that transparency and adding that flexibility, the goal isn't to have lots and lots of grades. The goal is to have a few grades that we can qualify lots and lots of species into.
Great, thank you. Michaela, anything you want to say on this topic? Anything else?
I would just add that, a lot of the mills are set up to accommodate small diameter logs. Obviously, the conversation is a little bit different in the Midwest and in the South and in New England. It's less federal land and more privately owned, state owned. And so, but the needs are the same. So that's kind of just all I would add there, that I would always appreciate the work Todd's doing, because the way that we can get more species in is by opening up those pathways from the certification standpoint and making sure those species are represented properly so that they're getting the right design values out of it. Because when you use, obviously our company is more on the side of using the traditional lumber grades, because that's how we're set up. But you take a hit doing it. Those visual grades are pretty conservative and for a good reason. But the more that we can all work as an industry to give more opportunities to different forests, I think it's really valuable.
Great, thank you. So maybe I'll ask one final question, and if anyone else has anything, we can entertain anything for about the next 14 minutes. But my question is around, like right now, Judith and I are working on a large kind of economic development proposal that's centered around mass timber in our region. And one of the questions we're being asked is, what's your vision for 10 years out for the mass timber industry here in the US? So that would be my question to you, is where would you like us to be as an industry in 10 years out? And what do you think are the key things that are going to enable us to get there?
I'll bite first. So, that is product development, is new, it's a design problem of both buildings and the supply chain. And I think 10 years would look like this needs to be very accessible, needs to be very scalable. And so whatever we can do in the complicated part up front to start to make this a lot easier to design with, so forth. Housing is the great example, because we're not heavy in housing right now because we have to be more cost competitive, or we have to ease the way for the code and jurisdiction acceptance. And when I think about the question earlier about housing, yes, we are not going to compete in the home builder market. That's not the intent. They have their model of low first cost. That's one thing. But that, for whatever the constraints of that growth are, that's not big enough to meet the demand. And in Washington, for example, the new governor came in, said 1.1, and the lieutenant governor, 1.1 million homes by this year. That equates to 50,000 homes a year. So that's the kind of challenge that I think is interesting for the mass timber industry to say, how do we contribute X number in Washington? Maybe the number is 10,000. This factory, I've done numbers on this. This factory was designed for Katera to contribute floor plates for housing. If we turned it on only to that kind of problem, perhaps we could supply 2,000-3,000 theoretical apartment floors, apartment flats a year. We need somebody to assemble all those. So these are big scale, but that's not even close to 50,000, right? So how do we do that?
Yeah,
so we need lots of these.
Yeah, 10 years down the road. One thing, I would just love to be able to drive down I-5 in Oregon and not see OSB. There's no OSB made in Oregon. Let's be honest, it's all imported from elsewhere. I'd like to have Oregon recognize our natural resources and the contribution to our rural communities here in Oregon of, sustainably managing these natural resources instead of, taking a NIMBY attitude that as long as it's not in my backyard, it's all well and good. And let's let China and Russia and everywhere else produce our materials for us instead of having a little bit of love and care for the manufacturers that are here local. The other thing that I would say is that, look, I mean, this is a very tough market. I mean, we've got still imports coming in from all over Europe that are really hitting the mass timber market hard. We're running on a one shift basis and fairly steadily on a one shift basis, but you don't put in a facility of tens of millions of dollars in order to idle it on one shift. You do it so you can put out capacity, and we've got a housing problem here in the United States, and I think mass timber is a real way to address that. Love to see enough market support, enough people becoming comfortable with the products that we could all start running our plants 3 shifts and start putting out massive amounts of affordable housing for all the people in the United States that are looking for it. That's what I'd love to see. I appreciate your support, Ian.
Thanks, Tyler. Michaela, view from the Midwest.
Yeah. Well, I mean, 10 years from now, my big goal, and when I talk about this standardization piece, like, I want us to be distributing like we would like on the industrial side. Like, for the industrial capacity, we're almost hitting, I think this year we're going to hit 1 million panels made. I mean, it's the scale is outrageous, and we want to bring that to the mass timber industry. And really, I don't want to call it the mass timber industry. I want to call it the construction industry. Like, we want to get so much wider than what people think is construction or is mass timber available projects. And so what I would love to see in 10 years is that we are doing a bunch of the single family tract home developments. Right now we're working with regional developers who are setting up regional fab shops to just buy our billets and take those billets and turn them into the projects that they need. And so I see a really strong opportunity for regional fabrication opportunities. And I also, I want it to get to be so commodity that everybody thinks of it as an absolutely normal material that you would put in anything, just like steel decking, just like concrete. And I think we're so close. And I think that it takes all these different manufacturers' approaches to get us there. And, ultimately, I want to distribute out of lumber yards. I want to be on the shelves of Home Depot for builders. Like, I think that there's an opportunity to make this just an obvious material choice. And it's so much fun to work with the graduates that are coming out of school now because they're getting this education and they're thinking about it so differently. Like, it is just a material that they consider. So, I'm really appreciative of what you guys do in the universities across the country to finally really be including this in that education, because it makes a big difference.
Thanks, Michaela. That's great. Well, thank you. That's been some really interesting discussion. We can close there, or if anyone wants to unmute and ask a final question, you're very welcome to. I saw someone's camera go on, but I don't know if that means you want to ask a question or wave goodbye.
Yeah, no, I just want to say, thank you. I don't know how I got here, how I got to the Meetup group, how I found it, but this is super, and I intend to share it with others that I think are interested in the conversation. And so thank you. And you see my contact in here. If you have resources and ideas, I like the recording. I'll share it with the other economic development districts, but in Oregon. But just thanks. It sounds like a lot of you are working on good things, and I think bringing more resources together is part of the key. So I appreciate the things I got to hear today, and that you let me ask dumb questions.
Hey, there are no dumb questions, right?
I don't know about that.
That's the way I operate my life phone anyway. I'm hoping people agree, but well, thank you. We do this. This is our 50th one of these. We started face-to-face in Portland, like going back 7 years ago now, I think, and maybe longer. Kind of moved online during the pandemic, and we're able to reach more people that way. We'll still do a few in-person events, but really glad you can join us. And this is meant to be kind of an interactive forum where It's not a bunch of university people lecturing about their work to another audience. It's industry, kind of communicating about all the innovations that are already going on, in the marketplace, and having a kind of a robust back and forth. So we welcome anyone to participate in these things in the future. We do have a Meetup group that we always put out the announcements about these things on our Meetup group. We run roughly one of these a month. We kind of take a break in the midsummer and Christmas holiday and that kind of thing. But thanks for being with us today. And thanks to the three presenters, to Todd and Michaela and Tyler, for sticking around, especially Michaela, 7:30 in Madison, I think. So
I think she's in Florida.
appreciate the effort. That's
8:30
right.
in Florida.
8:30.
Yeah.
All right.
Thank you, SU, U of O, Michaela,
Thank
Tyler.
you.
Good job.
Bye.
Thank